Hello everyone. This video is created for a course project in the Graduate School of Computer Science at Purdue University. The goal of our project is to evaluate the performance of QUIC, which is a transport layer protocol developed by Google in 2013. Following a paper called Taking a Long Look at QUIC, we compare the page load time of QUIC with that of TCP, which has been used for a long time since the beginning of the internet. We also evaluate the fairness of QUIC and TCP by varying the number of connections and measuring the bandwidth that each protocol consumes. In this video, we're going to give you a demo of our experiments. First, we start with setting up environments on Mininet. Then, we're going to show you how to compare the page load time and fairness of the two protocols.
Now, I will walk you through how to set up the environment to reproduce the QUIC and TCP comparison experiments in our project. As a prerequisite, you need to make sure that our GitHub repository is cloned into your Ubuntu machine, and also you have installed Docker in your Ubuntu machine. With that all set, cd into our repository, and there you have all the necessary tools you need to run our experiments. So one thing here is that we will need a lot of terminal windows to do all sorts of different things. So we'll need to open up different windows. I suggest you using the Tmux, which will help you open up multiple different windows within a same terminal window. So I will go ahead and then create a new Tmux session for setting up the Mininet. Now, create multiple window. In our case, it should be at least 5 windows to set up the Mininet environment. First, we want to do is to make Mininet. We provided a make file that will help you to set up all the necessary things. If you want to go with the default bandwidth with the Mininet Stratum Docker image, then you can just make Mininet, which will create the default 100 megabits link. On the other hand, if you want to specify a particular bandwidth, you can use the make Mininet bandwidth, and with BW equals to the number of bandwidth you want to set. As an example here, I will set a 10 megabits bandwidth. Now, it will start the MN Stratum Mininet image as a Mininet Docker image as you see here, and in the links you can see it consists of 10 megabits links. Now, in the second window, you need to install all the prerequisites. To do that, we have made this make command for you, which is Mininet make prereqs. Go with that, and then it will install all the necessary tools and set up all the necessary background processes to run different sort of things. Now, go into your third terminal window and make controller. This will start the owner's controller, which will set up the forwarding, which will allow you to set up the forwarding rules in the Mininet switch. So go make controller. This thing can be run together when the Mininet prereqs is being run, so don't worry about that. And wait for this make controller thing to stop. Give it a minute before going to do other make commands. Okay, so as you can see here in the bottom left, when you see this enter password or PIN for the NSS certificate, you should just press enter to enter a empty password. This password is to set up the database to enable SSL certificate when we want to set up the QUIC server or the HTTPS server. So go hit enter and then hit enter again, enter the third time, and then you should see this Unix path thing appear at the end and the terminal halt. This is the expected behavior. And here on the top right terminal, you should see when it says started something something and with 244, then it means the controller has started, and it should also halt here, which is also expected behavior. Now, go into your third terminal and make CLI. This will enable the owner CLI. The password is ROCKX, ROCKX. And then in the terminal and in the owner's CLI's window, enter ATP, activate FWD. This will activate the forwarding application, which is basically enable the switch to forward packets between the host in the mininet. Now, in the final terminal, enter make net CFG. This will install the forward table. Okay. Now I will pass it on to my other teammates to explain how you can run the different experiments, provided that this whole process has been gone through and your mininet environment is set up.
Now I will talk about how to do the file download time experiments with TCP. After you set up the mininet environment, please start another two terminals. For the first terminal, log into host H1. Then go to HTTPS H1 folder and start the HTTPS server. For the second terminal, log into host H2, then start the HTTPS client. Then the result will be stored in the result CSV file.
So in this part, I will show how to compare between QUIC and HTTPS or TCP for different configurations of file size and number of files, and for different bandwidths. First, I will start with starting a mininet environment. So with this make mininet bandwidth VW10 command, I can vary different bandwidths like 1 Mbps, 5 Mbps, 10 Mbps, and 100 Mbps. So let's start in terminal and run this command. So my mininet environment is running here, and after that I will install these prerequisites for the mininet. Sorry. Then I will start the controller with the make controller command, and then I will start the make CLI command, and the password is ROCKX. So after that, I will activate the connection using the app activate forward command. Okay. So my connection is established now. Now I need to activate the switches. That is the make net CFG command. And then I will enter into an host and start the server. So to start the server, this command is used, the QUIC server, where the certificates are mentioned and also the key file is mentioned with this macro. So like I have used it inside an Python script. There is server.py, and I will run the python server.py after entering into a host. So here it is, and then I will start the client.py, also entering into an host. So to run the client.py, this is a Google Chrome client, and which will be connected with the which will be connected with the QUIC server, and it will download files from the test.txt file. And so suppose I want to download 100 kilobyte files. So in that case, I will copy these 100 kilobyte files into this text.txt. Okay, so and with this client.py file, I'm calling this download function. Here is my command, and you can see that it is downloading files from the text.txt, and also I'm calculating time for each function call and accumulating them and obtaining the average time. So if I run the sorry, I need to enter into the host, and here is the client.py. It's there. So it's giving me the downloading time for download time for 10 files of 10 kilobyte, and also the average time. So after I obtain this download time for different configuration, like 5 kilobyte, 10 kilobyte, 100, 200, 500, 1 MB and 10 MB file sizes with different bandwidths, like 1 Mbps, 10 Mbps, 50 Mbps and 100 Mbps, and also like for different number of files, I will like load these like I will put these numbers in these like Google Note Python notebook. And also I'm using the TCP time divided QUIC time divided by TCP time. So the shorter the time is, the more faster the QUIC is. And after that, I will obtain these figures here, which are the comparison between QUIC and TCP, which shows the comparison between QUIC and TCP for different bandwidth and file size. As you can see that the darker green color means like the ratio is close to 0, which means QUIC is more faster compared to TCP. So you can see that for the larger file size, QUIC is faster compared to TCP. And so this is the way we have generated the heat maps to compare the file size, file download time between QUIC and TCP.
All right, now I will show you how to do the second part of our project, our experiment, which is the fairness comparison between the QUIC and TCP protocols using by establishing multiple QUIC and TCP connections under the same network environment. So first, you need to make sure that you have already started the mininet environment as specified in the previous part of this video. Here I will show you what it's like. I've gone through that. Now we will go through how to set up the environment, how to start the QUIC and HTTP server, and also the client processes. Right. Again, there are multiple terminal windows we will need to use. So make sure you have a way to start multiple terminal windows. Again, here I'm going to use tmux. So I'm going to create a new tmux session for the host. And now on the right side, I will be starting multiple, in total of 4 server processes, 1 QUIC server processes, and 3 HTTPS server processes. And on the left side, I will have 2 terminal windows, one for starting the Google Chrome client and one for running the TCP dump file, which will record the traffics. Now, before we start doing this, one thing to know here is that we are using ad hoc files for the servers to serve as their as an ad hoc website. So as you can see here in the directory, we have this www.example.org. This is the example website, the directory containing the files that the QUIC server will serve as the example website. So one thing I want to note here is that the QUIC server is very peculiar about the content of the website. So as you can see here, we provide two files. One is the index file and the one is the text file. The text file is 8 megabytes. Now, for every file in this ad hoc website directory, the first few lines of this file, no matter what format it is, it must be a valid HTTPS response. Let me illustrate this. Let's go into, let's open up the test.txt file. As you can see here, the later part is all zero. Actually, there are 8 megabytes of zeros in this file. But as you can see, the first part, it is a valid HTTPS header. We need to append this to every file in this example directory because QUIC server needs this part to correctly send this file, to serve this file as part of the ad hoc server, ad hoc website. Now, a few important fields. First thing is the content length here. The content length must be the exact length of the content, which is all the zeros here. In this case, it's 8. It is 8 megabytes of zeros in this file. The second one is this X origin URL. Here you will specify the corresponding URL for this file, which this is the URL that your server, that your client program will access to get it, to download this file. Okay, with all that said, let's go back to the root of the directory and let's go back into our host terminals. Now, on the left side, because I'm launching the client programs, client processes, so I want to go to the host 2. You can do this by using make host-h2. This will go into the mininet host 2, and the same thing, because I want to record the traffic out of the client host, we want to go into host 2. Now, on the right side, which I'm going to use to launch the server processes, I want to go into another host. In this case, it is host 1. So you just go to make host-h1. Now, do the same for the other 3 terminals, and then here you will be going into the host 1. Now, the work directory is the default directory. You will go into this Docker image, and if you see the directory, it is actually the same directory as our project root. So here you can just launch the server processes and the Google Chrome client. So you can do that by just following our README files in the GitHub project repository. There we have provided commands for starting the QUIC server. So here I will just copy paste them from the README. I will start 1 QUIC server and 3 HTTP servers. So I've just copied the command to start a QUIC server, and I will add another argument, which is --port equals 6121. This will specify the port for this QUIC server. Now, this is very important, especially when you want to start multiple server processes, because different server process cannot use the same port. So I will start that, and it will hot. It means the server process has started. Now, for the HTTPS server, you need to cd into HTTPS/h1, and then do Python server.py, and then the port number. In this case, I will use 8000 for the first server. I will do the same thing, but for the second server, I will use the port 8001, and for the third server, I will use the port 8002. Now, all 4 servers has been started. Let's go back and then actually start another Tmux window, because I want to show you a very convenient tool you will most likely to want to use when you monitor the traffic. So let's go to create another Tmux section. I call it monitor. And then here I will launch a GUI traffic, a network traffic monitor within the client host. So I will go to the client host, make host H2, and then start the iptraf ng. iptraf ng is a very useful GUI traffic monitor. So here, now because I'm on Windows, the color is off a bit, so I need to turn off the color, relaunch this program, and here is white and black. Now go to configure and then set additional ports. Make sure the ports, all the ports from 1024 to 65532 are recorded, are monitored, and then go to statistical breakdown by TCP UDP port, and then select the interface H2-ETH0. This is the interface to the switch and also connecting this host to other hosts. Now here, once we started the client process, the connections, we should expect to see one pair of UDP ports, meaning the UDP connection, and 3 pairs of TCP traffic. Each one corresponds to 1 TCP connection. Now let's go back into the hosts and start our experiment. So in the bottom left, I will use the TCP dump to generate a TCP dump file, which later we will show you how to analyze this file and also plot the visualize the traffic using Wireshark. So we'll use -i h2-eth0. This corresponds to the network interface of this host, and then -w, let's call it the TCP dump out. So this is the TCP, the file that it will write to. So let's start that and we'll start monitoring. Okay, now in this project, we provide something called a batch client cron, which is very convenient batch file for you to start multiple cron clients that connects to TCP and also QUIC servers. So we will use that batch clients cron. The first argument is the number of QUIC connections, and the second argument is the number of HTTP connections. Because we have 1 QUIC server and 3 HTTP server in this demo, I will use 1, 3. And now the traffic should have started. So let's go into the monitor. And here you can see, as expected, we have 3 pairs of TCP traffic and 1 pair of UDP traffic, which is expected. You can also see in the bottom here what is the protocol data rates, which means the throughput of this connection. So let's wait a second. You can see here the TCP, one of the TCP has already completed, and the second one has also completed. They have transferred about 8.7 megabytes, which is expected because that's the file size. Okay, now let's go back to the host. And now just terminate the TCP dump process, and then you should expect to see a TCP dump file. Now this TCP dump file itself, it's gibberish because it is a binary file, as you can see here. But you can use Wireshark to open it and then visualize the plots. I will hand it off to my teammates to show you how to open up this TCP dump output file and then visualize the plots. Thank you.
So this is Wireshark, and firstly we need to open the TCP dump file. We'll go to File, Open, and then we select where the TCP dump file is. Here we have our TCP dump file, and this displays all the packets. So now we need to generate the plots. So we go to Statistics and I/O Graphs, and to filter the packets for each client we need the port number. So we go to Endpoints, And for the TCP clients, we select the TCP traffic here, and here we have the port numbers for the three TCP clients we have. So we have 36076. Sorry, need to fill out the port here. Alright, so this gets the packets for the first client. Then we have the second client here, 36806. 6806. And the third TCP client, 46216. 46216. And for the QUIC client, we need to go to the UDP traffic, and we select the port number here for the single client, which is 55786. And this generates all the clients that we have.